Yes.
Good evening, everyone. My name is Isha Dabas, and I will be your host for today's webinar. Data science and machine learning are growing at an astronomical rate, and companies are now looking for professionals who can sift through the goldmine of data and help them drive swift business decision efficiently. Interested to find out everything new and exciting about today's learning? To introduce you all to the world of data science and machine learning, we have our speaker of the day, Mr. Sahil Sandhu. He is the core member at DSC-DCE, member at International Organization of Software Development DCE. He is also a machine learning and deep learning enthusiast. He is a finalist of intech, olympiad, and an aspirant data analyst. We are thankful to have you with us, sir.
So at first, I want to thank Isha for this introduction and thank you all of you for joining this session. So before starting the today's session, I just want to tell that within this session, we will not look at the mathematical part of the machine learning algorithms. We will just keep this session as simple as that and for the beginners friendly also. So let's start the today's session by looking at the today's agenda. At first, we try to understand what is the basic difference between artificial intelligence, machine learning, deep learning, and the data science. Although all the terms look very similar, but there are some basic difference which I think that a beginner must know before getting into this domain. Now, after that, we will look at which is the best programming language for the data science, whether it is Python or R, because unless and until we will not code, we will not get anything. So continuing it, we will start our technical part and look at the machine learning, its history, its introduction, and continuing it, we come to know we uh, okay, yeah. So we understand the different machine learning algorithms, and similarly, we introduce the deep learning part also. So after that, we the sixth part of the today's agenda is the data science project life cycle, and I think it is the most important part for the today's webinar. Just because here I will tell you about the different steps that you need to perform while dealing with any of the data set, and when you perform any operations on the data set. These steps that I show you here will be developed or will be done by all the business analysts and the great scientists that are the big data scientists also. So moving forward, we look at why are so much maths, and you have heard a lots of persons saying that you are doing machine learning, so you are good at maths. So we looked at how much maths are actually required to be a good data scientist. So whatever things that I show you here are not the only thing that you must be good at. So you can explore more, but the topic that I will show you and give you here are the basic requirements for the maths for the machine learning. So at last, we look at what is Kaggle platform. I think most of you have heard about that. So we'll look at it and explore it more. So let's start. So artificial intelligence, machine learning, deep learning, and the data science. So I want to start my webinar by a definition or by a statement that artificial intelligence is actually our final goal. So whatever we do, whatever we perform, whatever model we work, and whatever whatever code we write, so our final goal will be the artificial intelligence. So actually what the artificial intelligence does, artificial intelligence enables the machine to think without any human intervention. So it enables the machine to do to perform the task on the basis of the environment and the behavior from the learning that it learns from its past data and the experiences. So artificial intelligence is not a small domain. Actually, it is a very diversified domain. It is a very vast domain, and you can see that. Take a reference of the self-driving car. So you have heard that a self-driving car is an artificial intelligence. So artificial intelligence is a reference for the applications that we develop. But if you look at the implementation part, then we have nothing to code in the artificial intelligence. The models that we develop are developed in the machine learning, deep learning, and the robotics and the other thing also. So I said earlier that artificial intelligence is very diversified domain. Why? Just because whatever I showed here, it is not the artificial intelligence. Okay, machine learning, deep learning, data science, these are not the only thing. If we explore more, we come to know that robotics also come under the artificial intelligence. If we explore more, we can say that cloud computing somewhere incorporate with the artificial intelligence and the data. What we call it, data security. Yeah, data security also comes under the artificial intelligence, and we can incorporate all those both of these domains together. Why? Just because as we start handling with the difficult data and handling with the handling with a different model and difficult models, we need to incorporate it with the different domains. So artificial intelligence is just a diversified domain. Now moving forward to the machine learning. So at first, machine learning is a subset of artificial intelligence, and what it does, that it provides the statistical tools and the algorithms to explore the data. It helps us by providing the different types of algorithm, that what are the relationship exists between the data, and to explore more and more to the data. Similarly, looking forward, the deep learning. Deep learning is also a subset of the machine learning. So why we said that it is a subset of machine learning, not the subset of artificial intelligence? It is because if you look at the implementation of part of the deep learning, then at the very beginning stage, it at the very beginning stage, and we said, and I want to say that if we look at the single layer perceptron and the simplest layer perceptron, then there is something called the sigmoid function, which is actually, if we look, it is based on some of the most popular algorithm, the machine learning, that is the logistic regression. That is the logistic regression. And the sigmoid function that is used in the deep learning is actually used a lot. So we can say that deep learning is a subset of machine learning, just because it is using machine learning algorithm somewhere within it. And it is used a lot of the gradient descent, regularization. So it is used actually concept, it uses the concepts of the machine learning. So actually what happened when we try to work on the deep, when we try to explore more and more on the machine learning, we come to know that we have to perform such a type of task that learns itself. Just because machine learning models are limited to some extent, but deep learning are unlimited, and it will learn itself and continuously learn itself. So we developed the field of deep learning. Okay, actually deep learning is not a new thing. It was very developed very earlier, but it gains its importance and it gains the popularity since 2000. And it is just because when the Alexa comes, when the recommendation system comes into existence, then after the deep learning gains a very good popularity. Now moving for, yeah, I also want to say one more thing, that using the machine learning and deep learning, we can develop the models, we can make the machine capable to perform some tasks, and whatever the machine does later, we can see that this is the application of artificial intelligence. Okay, now moving to the data science. That what is data science? Actually, it is a technique in which we apply all the concepts that we learn from the machine learning, and the algorithms that are provided in the machine learning. We, along with these algorithms, we use the mathematical tools and the statistical tools that are provided in the data science, like the libraries that are provided in the Python, and the different, like the Tableau, which is used for the exploratory data analysis, and the different concept of the feature engineering. We apply all these things in the field of data science to extract information, to extract the suitable information, to extract what we required. Just like the recommendation system, what it does, it recommends something to you. So it is actually data science. Okay, so so why it is data science? Just because it gives some particular information to you from by extracting it somewhere from the structured or the unstructured data. I hope it is clear. Now moving forward, and let's start our technical session. Which is best, Python or R? So here we will not look at any of the implementation part, any of the code of the Python. We will not compare both of them, of the syntax, and we can't say that which programming language is good and the best, just because both of the programming language are known for their own capabilities, but also that both of the programming language are very well known in the field of the data science. So we compare it in the different perspective from the company's perspective. So at first, I want to say that R is basically used by the research scholars, research and development. Those scholars are working on the scientific part and researching something, new models and new algorithms, and are the mathematicians. They possibly uses the R, whereas Python is basically used by the programmers and developers who mainly uses the predefined models, who only uses those models and develop the different applications, like whether working on the backend part, whether working with the robotic operating system, working with the socket programming. So it is used by the programmers and the developers. Now R is only used, R has restricted itself for the data analytics and statistics part. We can't use R for developing anything uh, or anything else. But the Python is used for a different purposes. So it is used for the deployment and production also. So we can say. So I just want to tell you that Python is used in the different. Python has make itself enough capable that it can be used anywhere. It can be incorporated to with most of the programming language, and we can say that it is used in the backend part of the development using the frameworks of the Django, Flask. It is used in the socket programming also, and it is used in extracting the information using the SQL server, web servers, and the most important part, which is it is famous for, that is the Python. We can also develop the games using the Pygame, and we can also develop the GUI using the Thinker. There are lots of things that we can do with the Python, but R has restricted itself only for the data analysis. Now moving on, moving further, we can say that both the libraries provide the easy to use library, but the Python has an advantage of that we can develop a model from a scratch in the Python, but we can't develop model from the scratch in the R. Now Python runs globally and locally both, but R runs locally. Why? Just because R used for the data analysis part, that when most of your data are locally available to you, you have to just use it for you have so you just have to analyze it. Whereas in the Python is used for diversified fields. So sometimes there may be a case that you have to scrap the data from the during the using the concept of the web scraping, and maybe sometimes you have to deploy your model. So you have to deal with the AWS or the TensorFlow and the internet part. So we can work on Python globally and locally both. Now moving on to the famous ID that are provided by both of the programming language. So RStudio, we have listened a lot about this, and on the Python, PyCharm, Jupyter, like Jupyter notebook, it is one of the most famous notebook. And if you want to get good into the data analysis, that you have to get very handy with it. Now moving on to the IPython notebook. So the famous libraries that are provided by the R is ggplot2, caret, zoo. Now now moving on to the Python, pandas, scikit-learn, TensorFlow, caret. These are the famous libraries that are provided by the Python. There are lots of libraries that are provided, but I have mentioned two of them. So moving forward, these are the general general explanation about the Python. Now moving forward, yeah. So what is in this graph? So we can see that Python is more often quoted in the job description. Yeah. So I told you that we look at both the programming language from the company's perspective. Now from this graph, we come to know that Python is more quite oftenly quoted in most of the job description, but as comparison to the R, you can see that orange one is the Python and blue one is the R. But we can't say that as it is more often quoted in the as it is more often quoted in the program in the job description, then it is better than the R programming language, and companies use the Python more than the R for the data analysis part, just because Python is used in the different domains. Like it is used in the web development, also in the web application, in the socket programming, web SQL serving, and the robotic operating system. So we can't say that when any of the job description is created and Python is quoted there, so they are looking for the data analysis only. Maybe they were looking for the something else. Maybe they were looking for the Django developer, only the Python developer. So we can't conclude that Python is better than R from that. Moving further, yeah, this is a poll done by the KD Nuggets. It is one of the great website in the 2014, and it said that R is 58% used by the data analysis. Means 58% data analysts use the R programming language, where 42% data analysts use Python programming language. So they say that R is far better than Python for the data analysis, and maybe it is somewhere right, but that doesn't mean that we have to stop using Python for that. If you are a beginner, you have to start with a Python, just because Python don't restrict you to the data analysis part only. It helps you, so you can use Python in the competitive programming also. You can use Python in doing the in creating the website backend part also. You can use it developing the GUI using the thinker. You can create your own game, and there are loads of applications that you can use Python there. So you have to start with the Python, and even just because I am also using Python for the data science part, and there are loads of good libraries that you can use in the exploratory data analysis and the feature engineering part also. I also use the R, but I personally don't suggest you if you are a beginner. And and if you want to get into the research part, that you have decided that later you will do a masters and MS in the machine learning and the data analysis or the artificial intelligence, then probably you have to learn both of these. Because if you know only R, then in India definitely you will not achieve anything. At last you have to learn the Python. Now moving forward, important concepts of the Python, these are actually the basic concepts that I have mentioned here. I have written all this from the perspective of the data science, which I think that you must know in the Python. If you want to get handy with the data science, there are lots of other things that you have to explore if you want to be a Python developer. So at first I mentioned the list, dictionary, sets, tuples. So it is a basic thing, just because if you want to learn any of the programming language, then you have to start with the data types, and these are the data types of the Python programming language. So you have to get handy and with all of this and have to explore them a lot. Now moving on to the Python operators, if else condition, loops, keywords, break, continue. These are the basic things. Now Python string, different Python functions that are provided in the string, and now the Python function. Yeah, so all these things are very basic. Okay, now moving on to the complicated part, not the complicated but a very useful part. The advantages that are provided by the Python: lambda function, map function, filter function. These are actually the advantages provided by the Python, the special functions that are provided by the Python, which we often use in the data science part. And if you don't know about all these functions, then probably you can complete your task, whatever you want to do, you can achieve this. But it will look unprofessional kind of, just because if you have something, then definitely use it. Okay, so what does what the lambda function does is that uh, it will convert your small function into one liner function. The map function, like just assume that if you have a feature with a 200 values and you want to check that you want to divide all the values by 20, then you have to use the if else condition, the looping condition, if you don't know about the map function. But what the map function does is that it map, you have to provide the feature, you have to provide the value on which values, the list of the values on which you have to perform specific function, and you just again along with this you provide the condition that you want to perform. The filter function that divide the that divides the data on the basis of the conditions that you have applied. It returns true, false, whether on the conditions, like you want to know that how many data values are divisible by 2. So it will map all, so it will filter all these values that are divisible by 2. Okay, now the Python iterables and the iterators, these are also the basic things which you have to explore. Iterables and iterators, these are used to for the iterating purpose. Okay, now the oops concept. So obviously using the oops concept, you can figure out that how easy is the high level programming language. Means the oops concept is very useful even in the data science part also, just because inheritance, encapsulation, abstraction is somewhere useful, because it provides the data hiding part. Okay, now the exception handling, which comes under the complicated part but is very useful in some of the cases. when you don't have the data yourself. So assume a situation that you have to scrap the data from some website. Then you have to set the connectivity, you have to do the concept of the web scraping. So for that you have to create a connection with a website, or you have to set a connection. There it must be so there in such situations it is mandatory to handle the exception. Just because if you don't handle the exception, there might be a situation that most of when some there might be a situation when your system get crashed. Okay, similarly the when you are deploying your model, you are uh, when you are trying to deploy your model, so in that case also you have to check for the exception handling. Now the list comprehension and the string comprehension, they are also a very useful concept, and it allows you it saves a lots of time of your when you are dealing with the data, when you are dealing with the data when you are doing the feature engineering part. Actually it saves a lot of time here. Now moving further, important libraries to explore in Python. Actually, these are not the only libraries in the Python. There are lots of libraries in the Python for the data science part I'm talking about. So NumPy, Pandas, Matplotlib. So I'm mentioned is this just because these are the basic necessity that you must know before getting into this domain. But before starting the machine learning using the Python, so you have to know about all these things. Just because NumPy, the numerical Python, which provides you the different functions like the logarithmic function, exponential function, and so many functions that provides a complicated mathematical part. Now the pandas, unless and until you don't know how to get the data from your local system into your Jupyter notebook, then how can you perform any operations on that data? So there the pandas use, it is also used in the feature engineering part. Now the matplotlib provides the 2D plots with which we can check whether our data follows the Gaussian distribution curve or not. And we can extract a lots of important feature about information about our features. Now the Seaborn is also a plotting library. So with the help of Seaborn, we can plot the complicated curves, which provides a complicated information, which provides very useful and actually complicated along with the useful information, like whether our outliers are are far behind the +3 standard deviation, how many outliers are there, whether we have replaced uh, all the missing values or not, and so many information like that. Now the skikit-learn, yeah, using the skikit-learn, you don't have to there you don't have to uh, write the working of the whole algorithm by yourself. So here the developers have by hearted written all the code. So you just have to import those models, and you just have to put the training and the testing data on the models, and you will get the answer. So it provides the different types of matrices, the feature engineering matrices, and all. Now the TensorFlow, yeah. So TensorFlow is also useful for the neural network part. Keras is also useful for the neural network part. So with the help of these, you can create the neurons, and NLTK is used by the for the natural language processing. PyTorch does the same work as the TensorFlow and Keras, but the difference is that it is developed by the Facebook, and TensorFlow and Keras, TensorFlow basically is developed by the Google. Now moving further, what is machine learning? So let's start understanding it by a basic definition that was given by great scientist Arthur Samuel. That is the field of study that gives the computers the ability to learn without being explicitly programmed. And I think this statement is the self-explanatory. I don't have to say anything more. So there is one more statement, that is the Tom that was given by the Tom Michael. You can read here. So why we can say that it provides the computers the ability to learn without being explicitly programmed? Yeah, just take the reference of the self-driving car. How it works, how it knows that where he has to go, that how whether the car is approaching us, whether he has to take right, whether he has to take left, just because that machine is learning itself from the behavior that is happening outside and near to it. So it allows the machine to learn from the behavior, from the past, even from the past experiences. Okay, so machine learning is not the one that in which the machine learns itself. So most of the time we have to provide the data, we have to make the machine to feel that if such type of condition happen, then you have to take such type of steps. But in some of the time, we just provide the type of situation to the machine, and machine will try to figure out that what we will do that if some type of situation will happen. Okay, now you can see that Tom Michael explained it using the checkers game, that how the chess game will understand our thought that what we will choose, what we will do next, and on the basis of that he takes the decision that whether which so actually basically so basically he developed the checkers game for using the machine learning. Now moving forward, that machine learning is a growing technology which enables computers to learn automatically from the past data. So I must say that machine learning is a growing technology just because researchers said after research it was said that until the 2025, yeah, till 2025, most of the companies, even in India, not I'm talking about the outside, even in India, most of the companies, whether it is startup, it is the big tech giant, they started hiring for the data analyst, machine learning engineers, just because it is getting a good, just because it is getting a necessity in the daily life, just like you are eating something and using your phone. Similarly, machine learning is getting a necessity in the companies. So there are lots of job opportunities in the field of machine learning. And I also, along with this, I just also want to say that along machine learning is a growing technology. Along with this, it is a fascinating technology. Fascinating why? Just because even the developers don't know that how the machine will react in a particular situation. uh, just take the reference of the neural networks, that if you develop a neural network, you don't know that what will be the accuracy of that neural network and how it will behave, that how much better it will behave, and in which situation what it how it works. Okay, now there is the last statement that it uses various algorithms for building mathematical models and making prediction using the historical data information. It is very basic thing that I have explained earlier. So now moving forward, the types of the machine learning algorithm, there are three types of the machine learning algorithm: supervised machine learning algorithm, unsupervised machine learning algorithm, and the reinforcement learning machine learning algorithm. So let's start with a supervised learning. So what is supervised learning? So in the supervised learning, we are not provided with a out, so we are provided with the output feature, sorry to say, but here we are provided with the output feature. So here we know that for the particular type of input what we have to do. Okay, so here we give both the input and the output feature to the machine, and what we try to do, we try to find out the relationship that exists between the input and the output features. So there are different types of supervised learning, that is the regression and the classification problem. We look at it uh, while. So the most common examples of is the predicting the age of a person, predicting the house price prediction, determining whether the mail is spam or not. Now types of supervised learning, regression and the classification I told you. What is regression problem? So regression problem is that when we are provided with the data, input feature, output feature, and now we want to predict the continuous value within a range. So what we do, we map we map we yeah so we map the input feature into some continuous function, and using that we find out the continuous value. So common example is the house price prediction. Similarly, the classification problem, here we have to find out the discrete value. We have to classify that from which group it is get uh, which group it is. So yeah, classification problem. So here we try to find out the discrete values. So here we use the discrete function, and we are trying to classify the input features, and we try to find out from which group it is belongs to. So the most common example are determining whether type of tumor is malignant or benign. So we also use in the cancer detection also, and we also use it to the as I told earlier, the whether a mail is spam or not. Moving further, the most uh, important supervised machine learning algorithm, actually these are not only the supervised machine learning algorithm, there are lot more other algorithms, but these are the most common algorithm if you want to get into the data science, like as you are beginner and even you want to get a job after that, after that, you know, you have to get a very good knowledge about all these algorithms, just because these are very basic algorithms which are frequently used in the most in the regular data, different types of data sets. So first is the linear regression, in which we try to find out the best possible line, try out try to find out the best possible line on the values that are plotted on the 2D graph. So ridge regression, lasso regression. So what happens whenever we use the linear regression, there may be a case of the overfitting. So what the overfitting does, when you have outliers, so what is the outliers? That just assume that there are some of the features that have the unexpected value. So what it does, it will transforms the model in such a way that maybe it will behave good to the training data set, but it will might fail in the test data set. So in those cases we use the ridge and the lasso regressions, which with uses the basics of the linear regression along with the regularization concept. So here it does the regularization while finding the parameters. So moving on to the logistic regression, in which we try to find out that whether this value belongs to group A or group B. So it is used for the classification problem actually. So here we use the sigmoid function, as I told you earlier, that is also used in the deep neural networks, the nearby, the support vector machine. It is also the classification problem, in which we try to find out the best possible plane and try to divide out data on the basis of that plane. Okay, now moving further to the unsupervised machine learning. So unsupervised machine learning is very different to the supervised machine learning, in a way that here we are not provided with the data set. We are provided with the data set, but we don't know that what our output should look like. So here we have the input feature, but we don't have the output feature, that for a particular input what will be our output. So we have to find out on the basis of some our understanding, means machine have to find out. Yeah, so how we perform all these things, that we try to cluster the data on the basis of the relationships that exist between the different data points. So we cluster data on the different clusters, and all those clusters are very different from each other, but if you look into the data points that comes under some cluster, they have the same type of relationship. So the common and the famous unsupervised machine learning algorithm are the k nearest neighbor, so which try to find out the which try to predict the behavior of a particular data point on the basis of the k number of nearest neighbors of that data point. Now the k means clustering, which starts by by randomly choosing the three centroid, and based on those centroid we try to cluster the data. So these are very easy, but there are lots of maths behind that. It uses the Euclidean distance concept, now hierarchical clustering, and the principal component analysis. So principal component analysis is actually base are actually used on the decreasing the number of features that we are provided with. So you might think that why we have to decrease the number of features? If we are provided with a data set, then definitely it will be useful. So why will decrease the number of feature? So just try to understand that if you are provided with the data set, then it is not necessary that the whole data set will be given to the model, and the model will find out the best relationship between them. Just because at first we have to explore that data, whether this data is useful for us, whether this data is enough to get the best possible result that we want. And there may be a possibility, not a possibility, it always happens when you perform the different steps that I will tell you in this webinar, in the data science project lab cycle. Then when you perform all these steps on a particular data, your number of feature get increased, like the exploratory data analysis, feature engineering. Your number of features get increased, just because here you replace the nan features, and you cluster the data on the basis on the basis of different relationship. So increasing the number of cluster maybe lead to the overfitting and underfitting types of problems. So we have to we don't want such type of problems. So what we does that we only we try to find out that which is the most suitable features that will help in explore help in predicting the best result. So principal component analysis is used in such part. So it will tell that which are the important features and which are not. So it helps in decreasing the number of features. A priori algorithm, you can learn all this on the YouTube and the different platform. So actually, all these algorithm and the supervised learning algorithm that I will show you before, all these algorithms are complicated, and if we try to explain all this within this session, so it will take the time of the whole session. Now moving forward, reinforcement learning are totally different from the supervised and the unsupervised in a way that I think that they are the combination of both the algorithms. Now, so what we here want, so our main goal is to maximize the reward in a particular here our main goal is to maximize the reward by taking the suitable example, suitable actions in a particular situation. So what reinforcement learning does, that it try to increase the reward in all the cases by taking the different suitable actions from its learning. Okay, reinforcement learning is different from the supervised learning in a way that with a supervised learning we are provided with both the input feature and the output feature, and we just have to find out what the relationship exists, and based on this relationship we will further in the future find out that we will predict the output. But in the reinforcement learning we are not provided with the output feature, but our reinforcement agent know that what to get the particular output, what we have to do with that data. Okay, and in the absence of the training data set, it is bound to learn from its experience. Now moving forward, how the Instagram recommendation system works. So this is very interesting question, and after and along with this we will try to understand that how a neural network works. Okay, so we start the discussion on this topic with a two question, that which algorithm is basically used in the Instagram recommendation, and was this algorithm kept confidential from the world to make the Instagram number one social media platform? So the answer is actually no. Even the uh, developers don't know that how this algorithm actually works. Okay, so why I said all these things, just because try to understand that the basic thing that works in the backend part of the recommendation system of the machine of the Instagram is the deep neural networks. They are very complicated and the complex neural networks which updates its weights, and which continuously 24/7 all the time it updates its weights, and continuously increase or decrease the neurons as per the user experience and the activity that it performs on the particular platform. So let's start from the beginning. Let's just assume that you are watching some reels on the Instagram, and you are watching and you are watching some post on the Instagram, and you like that post, you comment on that post, you share that post, and whatever activity that you perform on that post, and just imagine that you have watched that reel more than twice or thrice. Then what happened, that Instagram extract all those features from your profile and convert all those features into a particular data set, in a very structured data set, and based on that data set it try to increase or decrease the weights of that neurons, or maybe increase the number of neurons, decrease the number of neurons, and based on those neurons it try to extract the same type of content that you're watching and that you are interested in. So it try to extract same type of content from the different from the other person's profile or the other user's profile, and it try to show all these things in your personalized feed. Okay, now there are loads of numbers or millions of neurons that works in a similar way. So some of the neurons and some of the algorithm might work in the long term interest, and some might work on the short term interest. So so like if you are interested in the fashion, that you spend a lots of your time in looking for the fashion and the different types of dresses on the Instagram, then maybe your long term interest is that fashion. So whatever you does, you will get a lots of posts related to the fashion thing only. But along with the short term goals, whether you are looking for a particular type of reel uh, for for a particular time, so you will get such type of reels for the shorter time. Now you can see that here I have mentioned that there is an efficient 3-part ranking funnel that extracts 65 billion feature and makes 90 million models predictions every second. So you can see that it extracts 65 billion features from the user profile, and on the basis of that it makes 90 million models predictions, whether it is doing updating the weights, decreasing the weights, and creating new neurons, and decreasing the number of layers. So it is a different thing, but it extract a lot of information. That's why we can say that Instagram recommendation system is perfect, just because it changes your personalized feed just after watching the 2 or 3 points continuously on the different interests. So it will change it will change your short-term interest very soon. Okay. Now there is one more thing that I want to tell you, that if you listen any of the fashion influencer and any of the blogger Instagram influencers, they always says that try to use the different types of hashtags on the Instagram post, so you will get more crowd on your data, or you will get more reach on your post. It is just because hashtag is one of the important feature that Instagram extract a lot. uh, Try to understand it why hashtag is important. Just because if you're like you have posted a photo of the fashion or of a dress, like you are posting your photo of yourself and you are mentioning the different types of hashtag, different type of hashtag related to the fashion, that then if some other person is looking for the post of the fashion, then maybe your post get reached to that person just because you have used such type of hashtags. So if you want to increase your reach on the Instagram, then definitely start using the hashtag. And you can see that here the other features that Instagram also extract of the user for the better working of the recommendation system is the like, share, comment, and saving option. There are lots of features that it extract. So I think that I have made it clear that how the recommendation system works. So moving forward with the neural network. So what is neural network? Deep learning. So yeah, first, neural network is a part of the deep learning. So why we say it a neural network? Just because uh, within the neural network, scientists try to mimic the human brain, that how the human brain work in the different situation and learn so effectively. And this response to stimuli is very great to the human brains. So they try to develop such type of model that learn 24/7 continuously while changing the data, while changing the environment, and it will just try to provide the best result. So they develop the neural network. So neural network actually, deep learning is a subfield of the machine learning, as we saw earlier in the graph, and concerned with the algorithm inspired by the structure and function of the brain, that how the human brain neurons works. So they develop the artificial neural network. So you can see that here I have mentioned a graph which is saying that as the amount of data increases, the performance of the neural network or the deep learning increases. Try to understand that why it happens. Just because on the older machine learning algorithms, what we do is that we try to find out the relationship which exists between the input and the output feature. But uh, but as you saw in the previous slide that I have showed, the recommendation system works. You can see that recommendation system is something that needs to update need to be get updated 24/7. Whenever you are using Instagram, it have to be updated for the each and every post that you see, that you like, and that you comment. So what it does, that it have to get updated itself from your short term interest. Okay. But machine learning algorithm doesn't work in such a way. So it updates itself once, and throughout their life period, unless and until you wouldn't update it, they work in the same way, and their accuracy will remain same. But the deep learning always try to figure out that how it increases its efficiency. So what happens, that whenever the deep learning new neural networks, and the neural networks first creates itself, so it checks its accuracy, whether it is 60%, 50%. Just assume it is 60%. So it back propagates itself to the starting, and it updates the neurons so that it increases its efficiency. Similarly, as I told you earlier in the slides of the Instagram, that looking at your features, that what you are doing and which post you are looking for. And so updates the weights of the neuron. Similarly, it back propagates and forward propagates continuously to increase the efficiency. So as the amount of data increases, just like as it continuously it extracts your information, the Instagram recommendation system continuously extracts the information. As the amount of data increases, the performance of the deep learning increases, just because it is developed in such a way that it increases its efficiency continuously. So now moving forward, you can see that here is a single layer perceptron, multi-layer perceptron. Within the single layer perceptron, we does nothing. Just we have the input feature, we multiply it with the weights, add them, and just pass it to the activation function. And based on that activation function, we get a result. So it is very basic, very simplest neural network, I must say. So this is a multi-layer perceptron. It is a very small part which I show here. Actually, such types of complicated neural networks are created in the complicated things that you saw in the Instagram recommendation system, in the Netflix recommendation system, even in the Alexa, Siri, or the self-driving car, or also based on such type of things. That's why we say that even the developers don't know that how your model will behave in the particular situation, and there it may be an uh, uh, yeah. So you can see that it is very small part that I have seen here. It is multi-layer perceptron. So there are also most of the complicated neural networks. Okay, yeah. So one more thing that I want to tell you, that the you can see that so I don't have the cursor. Yeah, so here is a cursor. Yeah, so there are the input feature, that input 1, input 2, input 3. So here we multiply it with the weights, we add them and pass it to the some sigmoid function, activation function. Now these inputs, these outputs of these particular neuron will become the input to some other neurons, and this process continues unless and until you will not get the result. So based on this, that it at last it will check the accuracy, that how what is the accuracy of the whole different types of different layers and the different neurons, and what the function it performs. At last it check the accuracy, and if the accuracy is less, it try to increase the accuracy by the back propagating and forward propagating, increasing the weights and trying the different paths. Okay, so sometimes for increasing the weights, for increasing the accuracy, what it does, it randomly drop out some of the neurons from itself, and there are lots of things that it does here. So it will get more complicated if I tell you more. So moving forward, CNN and RNN, it is the means these are the complicated neural networks, the convolutional neural network, the recurrent neural network. So CNN is basically mostly used for the face recognition systems, when you have to extract out the features from the images and the videos. And the RNN is basically used for the sentiment analysis and the different functions we perform with the statements and the English languages. And there are also RCNN. So there are also lots of the complicated neural networks. So moving forward, data science project life cycle. Now this is the most important topic of the today's webinar, so please listen it wisely. So we start with a data science project. So the first step of any project is the data collection. So just try to understand that it is not necessary that all the time you will be provided with the data locally into your system. You sometimes you have to extract it from the open source platform, like the Kaggle and the different website that provides the data. And sometimes you have to build up your data itself, build up your data sets as per your requirement. You have to scrap it from the from the different website using the web scraping, or you have to perform the different functions. Okay, so data collection is actually the basic requirement, basic things, like unless and until you don't have data, so what you will do, okay. So the first question, so the basic questions that you have to look at while handling with the data. So the first question is, uh, what type of problem are we going to solve? So unless and until you don't know that what type of problem what type of problem you don't have, so what data you will collect. Okay, so like if you don't know that your problem is the house price prediction, so unless and until you don't know that you have to predict the house of a particular area, so how will you collect the data? Okay, so first thing is that um, determining that what is the problem. Second is data source already exists. So after determining the problem, you have to check that whether the data source is already exists or not. If it is exists, that so you can use that data wisely, and you have to check that whether this data will be useful for you or not. If it will be useful, you can move to the other part, the other steps. But if it not, then you have to collect your data itself. Now moving to the third question, what private concerns are there at your whether you are collecting data from some website, and if it provides the data on money, that you have to buy it, or if there are some privacy concerns and with that website, so you can't use that website, so you can't extract that data from that website. So fourth step is the data public, that whether you are using extracting the data from some public source, like the Kaggle and the different platform. Even you can use it from use the GitHub for such type of data. So the fifth question is, where should we store the data? It is also one of the important, just because uh, in the college when we work on the data science project, so we will use a very small type of data set. So but when we start working on the real time in the companies on the real time data, so we can as I show you the example of Instagram, you can see that there we use a big there the developers use a very big chunk of data. You just assume that there are billions of users of the Instagram, and each Instagram user have their uh, own recommendation system, and they have their reels features. Uh, so those neural networks have to use extract that user data, so the data will get more complicated, and we have to find out the best source where we store that big chunks of data, so that we can use it efficiently. So whether we whether we have a very big chunk of data, so we have to decide whether we store it on the cloud, or we store it locally, and we store it in the data warehouse. So these are the basic questions that we have to look for while starting our project and while starting the step of the data collection. Now I assume that we have collected the data. Now we have to start the machine learning, and we have to start the data analytics part. So the first step is the data understanding. So here we don't plot any graph, here we don't use any function, we just have to thoroughly go to the data set and try to examine it, what this data actually trying to tell us. Okay, whether they are numerical values, categorical values, that it consists of the names of the peoples or the names of the cities, or whether the data is structured or unstructured, whether it contains the images and the feature, whether it contains the videos, natural text, speech. So you have to look all these things, just because it gives you basic thing that even if like someone else will ask a question from you, that which type of data it is, so what will you tell? So it gives you a basic understanding of the data, that what this data consists. Okay, now moving forward is the exploratory data analysis. It is one of the most important step, and if you want to get good in the data science, along with the modeling, exploratory data analysis and the feature engineering are very much important, just because unless and until you don't know what are the feature that you are working on, and what are the relationship that exists between the input features and the output features, and the relationship collinearity between the different features, so how can you perform any function on that? So if you're a beginner and you think that you just have to take the data set and just replace the missing value and just pass it to some model will work in its own, so you are totally wrong, brother. So you have to perform a lots of step along with the modeling part and the feature engineering part. So there are lots of steps that I will explain here. So first is the identification of variables and the data type. So this is the very first step of the exploratory data analysis. You have to first explore that what are the different data types, whether they consist of the object data type, whether they are numerical data type, or the uh, float data type. So these are the very basic stuff. Okay, so why do we need to do we need to perform this step? Just try to understand, because if you don't know that how many feature like how many categorical values are there in your data set, so how can you replace those values? Okay, so it is very basic step, and you will actually you will perform this step while you are doing such data understanding part. You are actually performing the same step. Now, understanding the feature variables, that is the training and the test data set. So here you you are trying to predict out what is the relationship that exists in the training data set, in the test data set. Okay, and this is important just because unless and until you don't know that what are the relationship exist between them, so how will you perform that, how will you choose that which model is better for that particular data set. Okay, third is the analyzing the basic matrix. So within the basic matrix, what we are trying to analyze is that what is the mean of the data, what is the median of the data, what is the standard deviation, third quantile, 75% quantile, 25% quantile, what is the most repeated value within that data set. If it is a numerical values, then what is the mean, median, mode, as I told you, as I already told you. Now, moving to the non-graphical univariate analysis. So, in the third step, we perform that step for the whole data set. Okay, but we find the we trying to find out the mean of the whole data set, and looking at the means, we obviously we look at the categorical feature up. We only use the numerical values at first, and then the categorical values at second. Now, non-graphical univariate analysis. So within this, what we does actually, we take each of the feature and try to analyze that what are the most important thing that are given in this feature, that how this feature is important. We have to analyze it, that what is the mean of that feature. Just try to understand it here. If you're provided with the data set, and if most of the values are nan values within it, so you have to replace that value. You can't just omit that values or drop that value just because dropping that values is not an option. If you drop that values, that means you are losing some of your information which might be useful for the for the development part on the model predicting part. So you, in most of the cases, you have to replace your values, nan values, or the empty values with the most possible values. So how will you replace that value? You have to figure out from that, from the non-graphical univariate analysis. Like, you will check that what is the mean, what is the median, and what is the 25% quantile range, 35 75% quantile range. What is the variance in the data, it whether your data has outliers or not. Now, the bivariate analysis. So what we does here, that take the two features and try to find out that whether there is any collinearity exists between the two features or not. Just try to understand that why we check the collinearity between the data. So at first, the collinearity is that what is the correlation between the two features. Okay, and why is it important? Just because if there is relationship between two types of features, then then among both of those features, only one feature we can use, and the second feature will be useless. Okay, as I told you earlier, that feature selection is one of our basic important part. So along with the feature selection, we have to look at the by by bivariate analysis. Just because if you have two features and both of them are correlated, just take the reference. Just for the sake of the reference, I take the example of the house price prediction. Like, you have this particular size of the house, like 500 gaj, 600 gaj, and 500 gaj. Yeah, okay, so I'm just taking any value. Okay, so as your number of the as your size of the house increases, your price of the house increases. Similarly, your size of the swimming pool. Okay, as the size of the swimming pool increases, your price of the house increases. So somewhere both of these features, that the size of the house and size of the swimming pool, are correlated to each other. So you have to find out that is there any correlation exists between them. And if it is exist, so you have to find out that which is the most important feature among that, and you have to omit the other feature. Okay, so there we use the bivariate analysis. Now, moving to the graphical univariate analysis. Here we plot the different types of graph using the matplotlib, seaborn libraries. And doing that is important just because unless and until you don't know that whether there is any outliers, whether your data is following the Gaussian dense Gaussian distribution curve, so you can't move on. You have to check that whether your data is left skewed, right skewed. Just because on the feature engineering part, you have to perform the regularization, feature scaling. So there you have to know all this information. Okay, So graphical univariate analysis helps you explore all this thing. Now the graphical bivariate analysis, now within this, it is similar to the bivariate analysis. Okay, it also helps in understanding that how much two features are correlated with the output feature. That if we increase the value of one feature and the size of the house and size of the output feature increases, and similarly if we increase the first feature, the value of the other feature increases or not. So here we try to predict all this information by plotting the different types of graph. Now the ninth is that is there any missing value, or do we delete it or replace it? So as I told you earlier, that we have our most of the important goal is to replace the values. We rarely delete any value or omit any value, just because deleting any value means losing some of the important features that might be useful in the future. So we have to find out that how many values are missing. Just imagine that you have a data set and with which most of the values are not a data set, that you have a data set and among one of the feature most of the values are blank and with the nan value. So what you will do with that value, how will you replace that value with some other value? So you have to omit that feature, just because how much important it is, just because it doesn't matter, but you have to omit it. Because if you replace it with some value like the mean value or the median value, then your model accuracy might get affected. Okay, now the 10th point is what are outliers. So I told you outliers in the very beginning of this session while talking about the linear regression. So outliers are those data that which are which are totally unexpected in our features. Okay, so how many outlets are there? So just try to understand that handling of outlets are important in the algorithms like the machine learning and the different such type of algorithms. Just because if we don't omit the outliers and we just directly pass all these values to the we just pass all these values to the model, then our model accuracy will definitely get affected, and there may be a problem of the overfitting, and overfitting that our model get better accuracy to the input features but on the training set, but it might get failed in onto the testing data set. So these are the step of the exploratory data analysis. Now moving forward to the data pre-processing. Okay, pre-processing is the third step, in which the first step is the feature imputation, so filling missing values. So replacing the nan values or the missing values with the most appropriate value will be the most important part, just because if you don't if you pass the nan value to the model, then what the model will predict? Just because just you don't have the value, then what the model will does? Now the different tabs of the so the different tabs that we use, the different ways we can predict the most appropriate value, and we can replace the we can find out the most appropriate value to replace it with a nan value or the missing value are the mean so the first is the single imputation. So what the single imputation says, that replace the value with a mean median mode. So what we does, it is very simple concept that here we replace the numerical values with the mean value and replace the categorical values with the mode value, that the most repeated value. Now the multiple imputation, what we does here, it model other missing values and fill with what our model finds. Okay, so here we pass our known missing values to the model, and that model predict out the most appropriate model, and we replaced it nan value with that predicted value. Okay, so also the knn is also one of the also the one of the most important algorithm. So it also used for finding out the missing feature. Now moving on to the feature encoding. So feature encoding is the second step of the data pre-processing. So it consists of different things like the one hot encoding, label encoding, embedded encoding. So what we does in the one hot encoding is just try to understand that you are provided with a categorical feature. Okay, you can't just feed that categorical values or the values, or the statements or the names to the model. Okay, just because all this data will be useless to the model, and we know that in maths we use we play with the numbers. So you have to map all these things, all this data to some to sum of the numbers. So in the one hot encoding, what we does that we turn all the unique values with the different values like 0, 1, 2. We can so I hope you understand that. Just assume that the you have a sex feature in the titanic data set. We have sex feature whether it is male or female. So one hot encoding, so how we convert it using the one hot encoding, we map that represents to the 0 and female represents to the 1. Okay, now moving on to the label encoder. What we does in the label encoder is that here we set the labeling to the different features that we have. We map the cat with a 0 label, dog with a 1 label, rabbit to the 2 label. Now moving on to the embedded encoding. So what we does here is learn a representation among all the different data points. Language model is a representation of 4 different words related to each other. So we also perform the embedded encoding for the feature encoding part. Now feature normalization. Yeah, so it is again the most important step, and usually it is important step in the deep neural networks and the algorithms like the linear regression or logistic regression. It is the most important part. Okay, so first is the feature scaling, second is the feature standardization. Just try to understand that why is it important. So let assume an example that you are provided with a data set in which one of the feature values ranges between the hundreds, and the second of the feature value ranges between the thousand, and the third of the feature value ranges between the lakhs. So you can see that there are very vast difference between the three different features of the particular data set. So how can a model predict such a value that in which one of the feature values are ranging between thousand, one is lakhs, and one is uh, hundreds. So what we does, we normalize those values between a particular range so that all our features and all the values of our data set will range between a particular range. So first is the feature scaling. So what we does, we try to map out all the features values so that it will vary between the ranges of 0 and 1. Now the feature standardization, here we standardize the values so that the values will have the mean, 0 and unit variance. Okay, here we subtract the mean and divide it with the variance of the data set with a particular feature. So what we does that for the particular feature, we calculate the mean and the variance, and then we subtract the mean and divide it with the variance. So using this, we does the feature standardization. So we perform it for all the features, and after performing it, we comes to know that all our feature values will map between the same range. Okay, and if we don't perform such type of operations, then our model accuracy will get affected a lot. Or to get a better accuracy, to get the better result, and to avoid the problem of the overfitting, underfitting, we have to use such type of features. Okay, now moving further is the feature engineering. Feature engineering, as I told you earlier, that is the important concept, and we have to perform all these things. Okay, so the first step of the feature engineering, the first thing we have to do in the feature engineering is the turning date. Like we are provided some feature in which we have mentioned the date, that whether it will be a date of birth, date of death, and any other date. So we try to map it in such type of format, or maybe in some different format. Okay, discretization, turning large group into the smaller group. So what we does is that just assume that we are provided with the same type of features which are closely related with each other. So what we try to do, we try to map all these features into a single feature, so that as the number of feature also increases, and we replace and actually what we does, we replace that less important feature with the most important feature. Okay, you can take the example like for numerical converting age categories into one. Like you are provided with the different categories, like for the people's having the age between the range of 45 to 50, 55 to 60, 65 to 70, as you are provided this such type of different ranges. So what you do is that you map all these you replace all these features with a new feature of the age, and you will write the age of that person. Okay, now for the categorical, what we do is that generalizing the green color, like light green, into one green color. So just try to understand that you are provided with the features that whether different types of green are mentioned, light green, dark green. So what we do is we replace all this feature with a new feature with a green, in which we use the label encoding that light green use the value of 1 and dark green use the value of 2. Okay, we perform such type of steps so that our number of feature also increases, and our data set will become more structured and more optimized for the model. Okay, now crossing an interaction, combining two or more features. Okay, on the basis of the correlation, that whether they are correlated or not, we combine two or more features. Now indicator features, using other parts of the data to indicate something potentially significant. Okay, so we have done the feature engineering part. Now moving further, feature selection part. As I told you earlier, it is one of the most important steps doing the feature selection. Okay, we select the feature on the basis of the priority, that how much it is important for predicting the particular output. We select those features. The first is the dimensionality reduction. Okay, we perform the principal component analysis. Okay, we perform this algorithm, and it will convert the small dimension using the linear algebra. Takes large dimension, yeah, so it takes the large dimensional data set and convert into the smaller dimensional data set. Now feature importance, we try to find out the importance of each and every feature. Okay, fit a model to a set of the data, then to predict the importance of the data. So here it will always so here it what it does, that it shows all the features on the basis of that importance, that which feature is more important, and it converts all this into the ascending order, that, which has the more importance and more correlation with the output feature. Okay, genetic algorithm, recursive feature implementation, elimination. So all these algorithm we can use them for the dimensionality reduction. Now dealing with imbalances. Yeah, just try to assume don't assume that there is some data set that is the credit card fraud detection. If you have explored that data set, then definitely you have some knowledge about that. But if you have don't explore it, then definitely try to explore it after this session. So what it consists that within that data set, there are lots of features that are provided, but within that features, there are very less number of the fraudulent transactions. So what happens when you have a very large when you have a very large number of the imbalance between the data set, that the number of the correct inputs, like the so what it does in the what we try to do in the credit card fraud detection. Yeah, so it gives the information of the different transaction that happen in the US or any of the other countries, and it will also consist of the data that which type of transaction are fraudulent. So we comes to know that the number of the fraudulent transaction are very less. So try to understand that if your other like the in the categorical features, categorical data set, if your number of if one feature is superior than the other, then the model get biased to the that particular feature. Okay, just because within the training data set you develop just try to understand that you divide the training data set and the test data set into 70-30%. So there may be a case that all the 70% means all the true values will get into the training data set, and all the false values will get into the test data set. Or maybe even you get a little number of values in the training data set, or maybe you will get a very little number of values in the test data set. So there are many of the situation that might happen. So in that cases we have to deal with such type of data sets. Okay, so the first thing is collect more data if you can. So what we do is that we have to collect more data. We have to collect the more data of the different type, that how many different types of fraudulent transactions. So we collect more type of data in respect to that feature. Now, and also other techniques. So there are also other techniques of dealing with that we will look at in the future, means in this slide. Now moving forward, the data splitting part. Now you have explored the data, so now you know that what the relationship exists between the data. Now you have replaced the nan values with the most appropriate values. Now what you have to do, you have to divide the data into the 70-80 or the 75-25%, and you have to test it and you have to test it on the model. You have to find out the best model that will give you the best result. Okay, now I have shown you that you can use any of the thing, like you can train divide the training set into 70-80% or the test set into 10-15%. Okay, moving forward, the training of the model. So training of the model can be done into the three steps. Okay, the first is choosing the model, second is overfitting the model, and third is decreasing the overfitting using regularization. So what we try to do that, first thing we try to do, find out the best possible model. What we does it, we pass the same type of data into the different types of model. Like if we have a classification problem, we find the same type of data to the random forest and the logistic regression and the other most popular ensemble techniques. Also we pass the same type of data, and if we and then we try to find, and we along with this we can also use the cross validation. What does the cross validation concept does it, it will divide the data, the training data that you are using. It will divide the data into the different parts, like k-fold cross validation divides the data into the k times. So what it does it, it will use that particular data among those of the k folds. So it will use one as a training, and so it will use one for the testing and the all others for the training data set, and it will try to map out which model performs very well among all those models that we are trying to use, and on the basis of that it will give the accuracy of the model. So so using the cross validation is one of the more better concept of choosing the model. So after choosing the model, we have to overfit the model. Try to understand, as earlier I told you that overfitting is a problem also, but here I am trying to tell you that uh, uh, overfit the model. It is just because if we try to overfit the model, then it will learn uh, more about the training data set. And as a model try learning more about the training data set, then we are extracting out more and more features. Then our model is learning more and more about the data. And at last, the third step is decrease the overfitting using regularization concept. So we can decrease the overfitting using the regularization. So regularization, how we the famous regularization are L1 and L2 regularization. So L1 and L2 regularization are nothing but the ridge and lasso regression problems. So also the dropout. So what in the does in the dropout, it is this concept is used in the neural networks where we drop out most of the neurons, with some of the neurons within the layers, the early stopping. This type of concept is used in the random forest where we stop the tree before before uh, before predicting the actual output. Okay, we stop it we stop it early, before showing the actual output, before getting to the whole depth. Okay, batch normalization, we can also perform the batch normalization for getting the for performing the regularization. Now the hyperparameter tuning. So actually what happens whenever we are using any model from that are provided in the different that are provided in the tensor in the scikit-learn library. So it have different types of parameters available, and that the different parameters are like the learning rate. So we know that we have to keep the learning rate as small as possible, but what should be the exact value, whether it will be 0.001 or 0.002 or 0.003. So what we does that we try to, after predicting after choosing a particular model, uh, we try to test our model on the different types of parameters that we want. Like we set the value of alpha. We choose three values for that, whether it will be 0.001, 0.002, 0.003, and also the number of epochs, that how many times it needs to iterate or performs on the training data set or the testing data set, like how many times neural network have to back propagate or forward propagates, and the number of trees, that how in the descent tree, that how many number of trees it will produce, that the number of iteration it will produce, and number of layers in the neural network, that how many layers it will create in the neural network. So all these things are the parameters that we have to provide for the better implementation of a model. So what we does that we will choose the appropriate value that our model will might take. Okay, so after doing all this thing, after providing, actually we'll provide the generalized values here, and from those generalized values our our model are tested on those generalized models or those generalized values, and from those generalized values it will show the best possible values for those hyperparameters. Okay, so what we does that we will pass those, if we pass those values that our model find out at the end, then our model accuracy get increased and it will perform very well on those values. Okay, so these are the basic steps that we have to perform on the data science project. Now moving forward is the analysis and the evaluation part. So this is actually also one of the important part, just because unless and until you don't know the accuracy of your model, how can you say that your model is good for the deployment and you can use it in the into the real world. So there are different types of method which we can use for the analysis and evaluation: the accuracy, precision, recall, f1, confusion matrix, mean average precision, that is used in the object detection. So so before using all this thing, you have to make it clear that you can't blindly use any of them on any of the model, and you can't use any of them on any of the data set. You have to first analyze the data set, and on the basis of that you can choose, you have to choose from those, you have to choose all the you have to choose that which value evaluation matrix you will use in the you will use for the evaluation. Okay, just like accuracy, you can't use accuracy matrix for the unbiased data set. That okay, just because if you use accuracy will give that what is the output value, what is the difference between the output value and the predicted value. Okay, so there may be a possibility that you will get a very good accuracy in your unbiased data set by using the accuracy evaluation matrix, that your model are performing well. Then you can think that your model are performing well, but in the reality that your model is performing worst on that case. So in those cases you have to use the recall and the precision, and maybe use the confusion matrix. So these are all these things that you have to explore before using. Okay, so for the case of the regression, we use the MSE, MAE, and R square. So other evaluation. So these are those things that are already provided in the library. Apart from all these things, you have to look at the different questions. You have to ask all this question from yourself, that how long does a model takes to train. During the training you have to check that how long it is taking train. That even in the future, if you will test it on some other data, that whether it will take the same time or not. So the second is the how long does the inference take, that how, and the third is that how does my model compares to the other model, that how, what is the accuracy of a model to the other model, that why this model is better than the other model. Because in what happens in some of the cases, that if your model is giving a good accuracy, that doesn't mean that it will perform well in the real life scenarios and in some other types of the input feature and the testing data. Okay, so you have to choose it why, if you are choosing a particular model, then why it is better than the other model. Okay, and what if we change something in the data, like if your data get a little bit changed, then whether it will affect the accuracy of a model or not. So moving forward, we ask that what does the model gets wrong. अगर model गलत निकला तो हम क्या करेंगे. Similarly, the bias variance trade off, that whether whether your model is biased to some particular set of data set or not. Now all these are the part of the analysis and evaluation. Now moving forward to the deploying of model. So what we does in that, we deployed that model that we have predicted, we have tested the data, we have tested data on that model. Now we have to predict in the different forms on the different platforms, so that the other companies or the other user can use it to analyze for using it on the and different application. They can use it for the different application, like you have here that most of the APIs of the machine learning are provided uh, in the TensorFlow, and for the Android user, it is just because they have deployed all that models in the form of APIs. Okay, so you can deploy your model on the TensorFlow serving, PyTorch serving, Google API platform. So what it provides, that here you can create you can make a model as a RESTful API. Okay, SAGmaker. So on this platform you can deploy your model. Now moving forward is retraining your model. So it is the actually the last case, and this is not the case, this is not the step that you perform only in the data science project, it is a step that we perform in actually all of the software. So what happens when you develop a software uh, and deploy it into the real world environment, then you have to update it as per the requirement of the user and as per the requirement of the client. So similarly, what we do here, that we increase its accuracy as the number of user increases and as the complexity of as the requirement of the client changes. Okay, so you might think that when the Instagram starts, so definitely they didn't have such good recommendation system. Similarly, when the Netflix was started, so they host a very good competition in which they give a millions of dollars to just increasing the 5 to 10% of accuracy to their recommendation system. So you might think that increasing the accuracy of a model and retraining a model is a continuous step, so you have to perform that step throughout the life cycle of your project. Okay, now moving forward, that why so much mathematics. So I think till now you have understood that why so much maths are required in the field of the machine learning. So you can take the screenshot of this part, just because I don't. These are the basic things that you must know before getting into the before starting into the deep into the machine learning and the data science, and actually these are the basic priorities. So what happens that why do we need such maths, and what is the importance of all these things are just just try to understand that if your data is following the standard normal distribution, okay, then your data is perfect. Okay, similarly the z score is also used in uh, most of the analytics part, probability density function, cumulative distribution function, hypothesis testing, that which hypothesis is your false and which is true. You have to predict it. Okay, covariance, yeah, what is the variation bit means what are the relationship between the two features, skewness of the data, whether your data is left skewed, right skewed, standard deviation, okay, measure of dispersion, range. So all these things are normal, are the basic requirements. Okay, so that is it. So after studying all these things, you can't say that you know all the maths of the machine learning, all the maths of the data science, just because there are lots of things to explore in that field, and even this is very diversified field, as I told you. So but what happened when you get handy with all these things, you will perform a lots of operation, you will better understand your data. Now moving forward, these are the statistics part, these are the linear algebra part, and the multivariate calculus. So multivariate calculus only consists of two parts, that is the differentiation and partial differentiation, which are mainly used in the grade in the gradient descent part and in the neural network part. Now moving on to the linear algebra, it consists of the matrix in vectors as a matrix. So basically, we used here is the inverse of a matrix and the matrix multiplication. So main concept is a matrix here along with the vectors. Okay, so all these things are important for you to understand before getting deep dive into the algorithmic part of the machine learning. Okay, just because just because unless and until you don't get handy with all these things, you will not understand better the implementation part of the machine learning. Because and if you will give interviews in the machine of the in the field of the machine learning as a data analyst, then the implementation part of the different algorithms will be asked in the interview. They will not ask that how will you use the tensor flow for creating the neural network and show it to me right now. They will not ask, but they will definitely ask that how the neural network back propagates itself, and how it forward propagates itself. Definitely such type of question will be asked. And as much I explored and I researched that most of the static question are also asked in the interviews. So uh, you have to explore all these things. Okay, now what is Kaggle? Yeah, so let's explore the Kaggle. It is one of the data science platform where mm, so yeah, you can see that it is the best data science platform in data scientists, where they can perform, learn, and research a lot. So let's start from the beginning. So this is a home for the Kaggle platform. So here, different companies and the different companies and the different hackathons are occasionally and or organized here, are regularly organized here, and you can participate in any of the competition. And if you perform well, then definitely you will earn all those amounts. Okay, you can perform, you can take part in any of the data science competition, okay, that are hosted here. Now, moving further, complete data. So here also consists of different types of the public data that you can choose for the learning part, for the implementation part. Like you are building such type of model and you are developing such type of particular project, then you can take any of the data set from here, which might be a requirement. So you can explore any type, like the heart attack and analysis and prediction data set, world happiness report 2021. So you can all this data set for your analytics and for the learning part. Okay, UK SARS-CoV-2. Oh, let me okay. Now the code part. So what happens, like if your system are not good enough to use all to perform all these things on your computer locally, just because what happens that in some of the parts, while deploy while uh, predicting, while working on the model choosing a model part, and while training our data, test data, and training of our data, during that period our model takes sometime it will take hours to get trained better. Okay, and even in the hyper parameter tuning, it will take a lots of time. And even if your Windows is like you are a window user and it is of 32-bit operating system, then definitely might be your TensorFlow will not work, means new version of the TensorFlow will not work. So you can use the Kaggle platform for learning. So you can develop your use their use this notebook. It is the Jupyter notebook that it provides. So you can use all this notebook for the prediction, uh, for the learning and the performance part. So let me back. And communities, uh, let's explore. So yeah, there is a lot of thing to learn. If you are a beginner and you want to learn a lots of things like the computer vision, if you want to learn about the uh, computer vision open cv library and how to perform the computer vision, if you want to know the cnn neural network, then you can use all these stuff that are provided for the free to learn. Okay, and even there are yeah, there are courses that are provided. Like if you want to learn the pandas, that I also learned the pandas from the Kaggle. So you can, if you are beginner and you want to learn the Python, you can use the Kaggle for learning part. Okay, intro to the machine learning, intermediate machine learning, data visualization. So all the things, all the stuffs that are most important, that are widely used in the machine learning, you can learn all these things from here. Okay. Mm, and the most important part is that uh, you can also check out the stuffs of the different data scientists, that how they approach to a particular situation, how they approach to a particular problem by looking at their notebooks that they have provided here. Okay, so I think all these are from my side. So I hope you will understand and hope this session will be useful for you. Thank you.
Thank you, Sahil, for such an informative session. Now, I would like to ask some questions to you. Why would one choose this field for their future?
Isha, as I told in the beginning of this session, that this is very growing field, and in one of the survey, it comes to know that till 2025, that most of the companies, whether they are startups, whether they are tech giants, start hiring for the post of the data science, data analyst, data machine learning engineers. Whatever be the post, just because we can't say that the post will be the data analyst only, the system analyst only, because they will decide, the company will decide what will be the post, but they will start hiring for the field of the data machine learning. Okay, the stuff will remain the same, the learning will remain the same. You have to learn all these things to get into this domain.
Okay, so my next question is, Is there any prerequisite we require for the following skill?
I think the basic marks is enough for that. Otherwise, all the stuffs you can learn from the Kaggle or the other platform. You can learn anything from the free for free from the YouTube. YouTube is the best platform to learn. Actually, I have learned a lot from the YouTube. Even if you want to start your career in the data science, you can take a very good course that from where I started. That is provided for the free on the Coursera. The Stanford by the Stanford University. Andrew Ng, a very great data scientist. Their core they have these course will be available always available for the free. You can use that course, and they have explained lots of things in very great manner. You can start your data science career from that position, from that platform.
Okay, so the last question for the day. What would you like to suggest to the first year students?
So I just want to suggest that start exploring, and whatever will you whatever be is your interest, start exploring in those fields. So I'm not saying that get into the data science, get into the start learning stuffs about the machine learning, because I have seen most of the student who means I have suggested to them just चल भाई इसी को पढ़ते हैं, and maybe they will not get interest in all these things, and they switch to the other stuffs like the android development, website development. So start exploring things and try learning things after you have decided that what you which position you want to work in the future. Just because it is all about your future, if you don't know, if you will not be happy with your work, then definitely you will not enjoy your work, and it will be the waste of your time. At last you have to change your domain as per your as per your interest. Okay, so don't get into this domain just blindly just because they are getting more hiring in this field. Just because I have listened most of the student who says that they have there is a hype of the machine learning, ऐसा कुछ नहीं है, ऐसा कुछ नहीं है भाई, हर चीज में स्कोप है, बस करने वाला होना चाहिए.
Thank you so much, Sahil, for clearing the doubts in such a precise and informative way. So, if any one of you have any doubt, you all can directly contact Sahil on his LinkedIn. We will mention his LinkedIn profile in the chat box in the YouTube as well. Hope to have many more sessions with you, Sahil.
Yeah, thank you, Isha.
Thank you.